Okay, we're going to start with the applications now. A paper flyer is to be made with 6 centimeter margins. Okay, they're talking about those. At the top, and 4 going left and right. So the printed is right there. And around that printed area, it's going to be plain, you know, like a frame around a photo. If the printed area, so remember, look at this, that is X and that is Y. The printed area, which is the green, that's XY, that is 216. They're asking for square centimeters. They're asking what dimensions of X and Y will minimize the total area. Area total is this length. If this is X, this is 4, this is 4. X plus 4 plus 4 is 8. And the width is Y plus 6 plus 6 is 12. That is X plus 8 into Y plus 12. And if I FOIL this out, that's xy plus 12x plus 8y plus 80, and 12, 90, 96. Is that right? 8? Yep. Now, notice I know that xy is 216. So now I know that area is 12x plus 8y plus 12, 9, 10, 312. Well, we have a problem. There are 2 unknowns in this equation. I need to get rid of one of them. Well, if I know that xy equal 216, then I could say y is 216 divided by x. Take this quantity and put it right there. And what that does, that will convert the problem and make it a function of only one variable, x. And now I could say, look, if I take a derivative of a, because I'm maximizing a, that is 12x, 8, and I'm going to leave that as 8 times 216x to the negative 1. Bring the power down, that's going to become negative 8 times 216x to the negative 2. I messed up. The derivative of that would be 12. There you go. And you know what? Minus 12. Let's get it out of the way. I'm going to multiply this out and come back. Okay, so I got it. I'm getting a to be 12x plus 1728x to the negative 1 plus 312. When I take a derivative, that's 12 minus 1728x to the negative 2. That is 12 minus 1728 divided by x squared, or simply a prime is 12x squared minus 1728 divided by x squared. Let me give myself a bit more space. And we're going to say, look, where does that equal 0? Where does it not exist? Well, it does not exist if x equals 0. That's very simple. If you want the smallest area, just don't make it. And if I take 17x squared minus 1728 equals 0, I'm getting x squared to equal 1728 divided by 12, which is, let me divide. Okay, I'm getting that to be 144. That means x equal plus or minus 12. We're going to take 12 only. 12, a prime. If I pick a point to the left, say 1, 12 minus 728 is negative. And if I pick 13, that's going to be positive. So we have a minimum area when x is 12 and y is, what is 216 divided by 12? Let me work that out really quick. So that is 1. That is 2 out of 11, 96. And that is 8, I believe. 8, 96, 18. So x is, did they want the whole? Let me see. What dimensions of x and y will minimize the total area? Well, x equal 12 and y equal 18, or simply the total area. If you're going for total area, 12 plus 4 plus 4, 12 plus 8, 20 by 18, and 12 is 30. And what are the units? Centimeters. Yeah, but it says what dimensions of x and y. That would be the answer right there. Okay. If they would say find the total area, you multiply those two together. But that's the answer. 12 or 20, but yeah. Okay. Same thing here. A road perpendicular to a highway leads to a farmland that is 1 mile away from the highway. They're saying this is 1. A car travels past the Hara speed of, call this x, dx dt is 60 miles per hour. How fast is the distance between the car and the house? Call this y. They're asking what does dy dt equal when, how fast is the distance between the car and the farmhouse changing when the car is 3 miles past the intersection on the highway? Well, what do we know? We know that y squared equal 1 squared plus x squared. If I take a derivative with respect to t, 2y dy dt equal 2x dx dt. The 2's cancel out. If I multiply by 1 over y, dy dt is x over y dx dt. Well, now what? Dx dt is given to be 60. X is given to be 3. What's y? Well, there's y, there's 1, there's 3. Doesn't that say y squared equal 9 plus 1? So isn't y radical 10? So dy dt would be 180 over radical 10. You could rationalize, you don't have to. What are the units? Miles per hour. And there it is. So what they did here, they gave you one of each. You know, one area, one surrounding, one three-dimensional, and then later on one distance, rate, and time. Similar figures. Okay, well, let's see how this works also. A 10-foot high shed with flat roof and 3 walls. Okay, the walls are right there. This one, and the back. Is to be constructed as illustrated. It is required that the shed have 800 square feet of flooring. 800 square feet of flooring. Okay, the floor is, this is y, this is x. The floor is xy, and that needs to be 800. Material for the roof costs $2 per every square foot. Material for the walls cost $1 per square foot. Again, these are the cheapest normally. And the floor is the most expensive. cost $3 per square foot. Okay. Two for the roof one. What dimensions of X and Y? They're looking for X and Y. We're getting the cheapest shed. Well, here, the surface area is area at the base, which is XY, that's the floor. Area for the roof, which is XY, and I'm not combining those because the cost is different. And this wall right here is 10Y. This wall right here is 10Y. And this wall in the back is X by 10, 10X. Now I'm minimizing the cost. The cost function is take the floor and multiply the floor by $3. Take the roof and multiply the cost of the roof is $2 per square foot. Of course, that's the footage. And take the floor, the walls, which is 20Y plus 10X, and multiply that by the $1. And now I could say the cost function in terms of X, Y, and Z is 3XY plus 2XY plus 20Y plus 10X. Or I could simply say the cost function is 5XY plus 20Y plus 10X. Now, I know that XY equal 800, so Y equals 800 over X, or 800X to the negative 1. So my cost function is 5X times 800 over X plus 20 times 800 over X plus 10X. My cost function is 4,000 plus, what is that? 16,000 x to the negative 1 plus 10x. And if I take a derivative, the cost function would be negative 16,000 x to the negative 2 plus 10. And if I work that out, I'm looking at negative 16,000 over x squared plus 10. I lied. That's the change in cost, yeah? That is negative 16,000 plus 10x squared divided by x squared. Again, where does the derivative equal 0? Where does it not exist? It does not exist if x equals 0. Well, don't make it. That doesn't cost you anything. And c prime equals 0 when negative 16,000 plus 10x squared equals 0. So that is when x squared equals 1600, x equal 40. And I could check really quick. 40, there's the cost function, the derivative right there. If I pick 1, negative 1600 plus 10 is 2, it's matching. I have minimum cost when x is 40 feet and y is, if I put 40 right there, 800 divided by 40, that is 20 feet. Okay, the next problem is not going to take that long. 15. It says, given the following diagram, find the limits. Now I'm going to highlight and erase the highlights. As x approaches 2 from the right, so you're coming from the right side, from the very right side, as you get very close to 2, what's y leveling off next to? How about 2 from the left? If I'm coming from the left side, isn't that running down to negative infinity? How about negative 3? Negative 3 is right there. Negative 3 from the left. From the left side, what is y leveling off next to as I get very, very close to negative 3 from the left? And how about negative, oh, I messed up. Negative 3 from the left we said was negative 2. This is negative 3 from the right. From the right side, this is negative 3. What's y leveling off next to? Isn't that 0? Now, when it says, what's the limit as x approaches negative 3? Keep in mind how this works. If I wanted you to do those two parts, I would have just asked that question. Because if I say, what's the limit as x approaches negative 3, you have to check the limit from the left and the right. If they don't match, you say it does not exist. And if they match, you tell me whatever that number is. I'm going to erase some of this because I cleared the graph really quick and restart the process. Now, what is the limit as x approaches 0? 0 is right here. From the left, it's approaching infinity. From the right, it's approaching infinity. We say that's infinity. What's the limit as x approaches 4? 4 is right there. From the left side, that's 2. From the right side, that is 2. Even though f of 2 is 1, f of 4 is 1, it doesn't matter. Limit, you never get to the point. What is the limit as x approaches infinity? To the far right, isn't y leveling off next to what value? What is that value right there? Isn't that 4? And how about negative infinity? How about if I'm running to the negative side? What is that y value leveling off next to? Isn't that negative 1? And there it is. At what numbers is f not continuous? Okay, f is not continuous. Remember what continuous means. I trace the graph left to right. Wherever I lift my marker off the page, so when I get to this point, I have to lift it to go up there. So not continuous at x equal negative 3, 0, 2, and 4. Oh. What type of discontinuities is it? Well, here, if the limit from the left and the right don't match, that's a jump. Since at 0 you approach infinity from one edge, another, that's infinite. At 2, it's also infinite on one end. And at 4, the limit from the left and the right match, but f of 4 is 1, we call that removable. Okay. Use the following graph to answer the questions. This is the graph of f of x, people. At what numbers is f not differentiable? Wherever f is not continuous, it's not differentiable. And wherever you have a cusp, it's very hard to see this, but at this point here, we have a vertical tangent. But if you don't see that, that's okay. So x equal negative 1, negative 2, negative 3. This is negative 4, negative 1, a corner or a cusp. At 2, it's not continuous. Again, if you don't see 5, that's okay. What is the value of f prime of 4? At 4, what's the slope of the tangent? That's 0. And what is, which is greater? The slope of the tangent at negative 2, the slope of the tangent looks something like this. Or at negative 3. At negative 3, it looks like this. Isn't this value? Let me make sure. Negative 1, oops, I messed up again. Okay. Let's go negative 3 first. At negative 3, negative 1, keep saying that's negative 1, negative 3, this is the slope of the tangent right there. And at negative 2, negative 1, negative 2, it's at that point. Isn't it? This is bigger than that. So f of negative 2 is greater than f of negative 3. Of course, slope of the tangent, not the y values. Okay, and evaluate the limit. Well, the limit, you substitute it in, that's the shortcut. That's f of 1. So that's x approaching 1 from the left over 0. What's f of 1? Look at the graph. f of 1 is a number, some value, right? And it's positive. So this is a positive value. You want to know if this is positive or negative. If I pick a point to the left of 1, say 0.99. If I put 0.99 minus 1, I know the answer is either positive infinity or negative infinity, because any number over 0 other than 0, you get positive or minus infinity. We know that from the limit section. I want to know, is it positive or negative? 0.99 minus 1 is negative. Positive over a negative. The answer is negative infinity in this case. And I'm going to stop here for this video. And I'll wrap the rest in the next video.